In the lesson 1.8 example, how well did Lionel do, we're going to find and interpret a z-score. Mr. Pryor gave a statistics test for which the scores are shown in the dot plot. We want to find the standardized score, also called a z-score, for Lionel, who earned a 67 on Mr. Pryor's first test, and we'll interpret the value in context. Now, one thing I want to emphasize is a z-score tells us how well Lionel did relative to the rest of the class. And to illustrate that, I want to show you something. Had we not known what these scores were here, we might have thought, well, maybe 67 was a good score. Maybe this was 67, or maybe this was 67. Maybe Lionel did the best in the class. But with this, we can see that Lionel actually did not do the best. In fact, he got the lowest score in the class, and we want to see how he did relative to the rest of the class. So a z-score is calculated as the value minus the mean all over the standard deviation. What it calculates is how many standard deviations different from the mean this observation happens to be, with a negative z-score indicating that it was below the mean, a positive z-score indicating that the value was above the mean. So Lionel's value was 67, which again just happens to be the minimum. The mean was 80, and the standard deviation was 6.07. None of the rest of these values serve any purpose in calculating the z-score. We're going to plug those values into the z-score formula and obtain the value of negative 2.14. What that means is that Lionel's score is 2.14 standard deviations below the mean of 80. This confirms what we knew before, that Lionel's score was quite low relative to the rest of the class. If you'd like to do a problem like this in your textbook, you can try exercise 9.